So statistics is a science of data. And if you look at univariate analysis, it's got the word uni, which means one, and variate for variable. It just deals with a single variable. So if we're just looking at shoe size, data that you collect when they do statistical analysis is either qualitative, which is descriptive, right, or quantitative. So if I wanted to know how students felt before a long weekend, I probably wouldn't take quantitative data. It's like, oh, I feel like a 3. I feel like a 5, right? You can make a scale. Sometimes there's a scale which tries to quantitate feelings. Feel terrible that we don't get to come to school on Monday. It would be at 0. Or feel great that we get an extra day to study for our math test, 10. So sometimes we quantitate qualitative things, but we usually use quantitative stuff for things that we can measure. And we've seen this in probability already. In probability, especially binomial distribution stuff, we were looking at discrete data. You can't flip a coin 5 times and get 3.7 heads. Okay? But there are some data that is continuous, like we talked about already, your height. Your height slowly grows. So those are some examples of discrete and continuous data. And we talk about everybody that we're studying as a population, but sometimes it would take too long to study everybody, so then we look at a sample. So in Canada, sometimes they want to figure out who's going to win the next election. They don't phone every single person and ask them, because that would take too long. So they get a sample, and then they use that sample to try and make predictions. But when we get an election, well, I guess an election kind of is a sample too, because not everybody votes, but everybody could vote. And so then that entire population. So you've got sort of a picture. Your population is a big thing, and your sample is just a part of it. And in a lot of statistics, we're really concerned about getting a random sample, because then your data is more realistic, right? If you wanted to predict the next election and you just asked people at the Liberal caucus meeting who they're going to vote for, you might get a real biased sample. So you need, in order to have a random sample, everybody has the same chances of being picked from the entire population. And so you're hoping that your sample has the same characteristics as your population. So instead of just listing all of your data separately, one thing that we tend to use is something called a frequency table, which lets you organize your data and then look for patterns. And then you can show your data in a bar graph. We're going to also look at histograms. So here we have a bunch of data. Again, we got a nice fish example. How many fish were caught in a net every day for 30 days? And when we look at that data right away, the way that it's given to us, it just looks like a bunch of numbers, and it's a bit overwhelming. It doesn't really tell us that much. But if we start to look at the numbers that are there, we've got the numbers from 10 all the way to 18, and if we count them up and tally them up, all of a sudden our data starts to mean something. And if we always put our frequency on our y-axis and what we're looking at on our x-axis, then we can draw a bar graph, and that also can start to tell us some information. So now we can look at our calculator, and our calculator can figure out a lot of stuff for us. It can figure out our mean, our median, it's going to find our standard deviation, our quartiles, our max and min values. So the first thing we're going to do is we're going to look at the data that we just had, and we're going to put this into our calculator. So we're going to go to our calculator. You're going to hit your stat button, and then go to edit. And depending on what we've done, you might have stuff stored in here. Now, if you have stuff stored in there, you can go and individually delete each thing, which could be time consuming, or you can delete a whole list. Now, be careful, don't do it yet, because your gut feeling for deleting a whole list would be go to the list and hit delete, right? Does that seem like a logical thing to do? If you would go to if I would go to list 1 here and hit delete, it deletes list 1, not only the data, but everything. List 1 is no longer an option. Now, there's ways to get it back, but it's not fun. So instead, you use the other intuitive thing that you would think of next and hit the clear button and push down, because that's obviously what you would think of doing when you want to delete everything. You wouldn't just hit delete, right? They should have an option. Would you like to delete the entire list or just delete the contents? And then you could toggle, because that would be what I would normally do. So I have many, many times deleted my whole lists. And then you have to go to the end of your lists and rewrite list 1, and then rewrite list 2, and rewrite list 3. And it's kind of annoying. So we can delete our data by just going up to the list, hitting clear, and then down. Okay. Now we can go and enter in all of this data, and it doesn't matter the order. Okay, so I would like you guys to enter in all of the data that it is there, and I'm going to enter the data as my frequency chart was. Okay, so you're just entering in all of the data, doesn't matter the order, and I'm entering in our frequency chart that we made. Because I want to show you two things. Okay? Here's my frequency chart here. 334. Yes. Okay. Now, your calculator instructions that you have here, the calculator instructions you have here is for a single list of data. So if you've got all of those data points listed in there, what you're going to do is you're going to go stat again, just stat, go over to calculate, and the very first one is 1 var stats, and you will just have your list as list 1, and you will have nothing in your frequency, and you'll go down to the bottom and hit calculate. Okay? If you have the older calculator, you have 1 var stats, you can just, after that, well, it'll automatically take from list 1, you can just push enter. Okay? Now, because I put mine as a frequency, I'm going to get the same answers that you get, but I put my list in list 1, and I'm going to go second list 2 to say the frequency. And what that does is it put in all of those data points the same as you put in, just maybe a little bit quicker, because I didn't have to put in 18 6 times. Now, when we go to calculate, we should both get the same numbers. Did you get an average of 14.43? Okay? This one here says that if you added up all the ones that you put in, it should add up to 433. If you decided to take every number that you put in and square it, and then wanted to add it up, you would get 6,489. Now, You might think, oh, that's really weird that you're telling me that, but we're going to need those numbers in statistics. Now, important things that we do like to know are 2.82 is our standard deviation. So if this follows a normal distribution, we just figured out our standard deviation of this data. There were 30 numbers in total that we entered. The smallest one was 10. The biggest one was 18. The median, what would be right in the middle, is 14.5. Now, there was no 14.5 when we listed things, but because we have 30 numbers, does it make sense that the middle is going to be somewhere between the 15th and the 16th number? So the 15th number was a 14, and the 16th number was a 15, so we would say our median is 14.5. We don't know what these are yet. We'll learn about them in statistics. Quartile 1 and quartile 3 are not hard concepts. They're just the first quarter and the third quarter. So if you had a median being right in the middle, Q1 would be in the middle of that bottom middle, and Q3 would in the middle of the top half. So it gives you an idea of what your data looks like. Scrolling down further, scrolling right at the top, we X with the bar over top of it, just again, that is our average. It's another symbol for the mean. So if you added them all up and divided, that's your average. So what this does is it calculates a lot of things for you quickly. Because how would you have found the average before? You would have added up all 30 individually, got that answer, and then divided by 30 to find out what the average is. So this allows us to do things a lot quicker. And now that you've seen how to do it with a single list, I've also shown you that if you put your list and a frequency, you can do that as well. Okay, and that's what your instructions are after. I showed you how that worked when you put in a list and a frequency. All of those numbers tend to be the same. Okay. So when you have lots of data, it often makes sense to group things together and then figure out a frequency for them. So especially when measuring different human traits. Like if they're measuring heights, if we measured everybody's height in this class to the nearest 1/10 of a millimeter, no two people in this class are exactly the same height. And if we listed all that data, it would be each individual heights. But if instead we wanted to say, well, how many people are between 5 feet and 5'4"? How many people between 5'4" and 5'8"? How many people between 5'8" and 6 feet? 6 feet and 6'4". And we grouped people according to that. That'll tell us some more information. Now, certain groupings might be too wide. Like if we said, well, I wonder how many people in this class are between 3 feet and 7 feet. Well, we just get one big bar, because everybody would be in there, right? And if we separated it too small, like to the nearest 1/10 of the millimeter, and drew a histogram, we would get a bunch of bars that are all one height of 1, because nobody would get grouped together. So depending on how we group that, we can make a histogram. Now, a histogram is like a bar graph, but it has no gaps between. Before we drew a bar graph, we had some gaps. The width of each bar is the same, and it's the width that you've decided to measure things by. And you make a frequency table based on that. Again, our x-axis is always our topic, and our y-axis is our frequency. And we can create histograms on our calculator. So here are the instructions. We will do these instructions for some of the examples that we have. So we'll come back to this. The order is a little bit interesting because you zoom and then you change your window after you've zoomed. So that's something to be aware of. So here's our first one, and we're going to make this and do this on our calculator. So from here, we are given the histogram. Our histograms width are each in 20s. So when we look at our age range here, we're going from 0 to 20, 20 to 40, 40 to 60. And notice that there's an equal sign with some of the values, but they're not. That way, if someone is 40, exactly 40, they'll fall into this third category. They won't fall into this one. Now, looking at that, how many people are between 20 and 40? 70. Okay? So it's not hard to figure out these numbers from your graph. Right? When you go between 40 and 60, there's 100 people that happens with. Now, when we go to put this data into our calculator, because we don't know the actual ages of those 40 people between 0 and 20, we just assume they're all 10. We use the midpoint value for getting an idea of what the average age of this group is. If we wanted to find out what the average age of this group is based on those frequencies, we're going to assume everybody between 0 and 20 is 10, 20 and 40 is 30. So we're taking that midpoint value because that's the best estimate if you would look at that group of people. So our interval width is 20. And now if we wanted to calculate an estimate for the mean age, well, we would take those middle values, and this is basically saying we have 40 people who are age 10, 70 people who are age 30, 100 people who are at age 50, 50 people at age 70, 10 people at age 90. So if you're figuring out an average, you would add those all up and then find out that the frequency adds up to 270. So we get an average of 44.1. So once you're done writing that work down, if you want to go to your calculator and put into list 1 the actual values, and frequency always goes into list 2. Again, don't delete your data from before, just go clear down. And I'll enter it into my calculator as well. So if you've been able to enter that data into list 1 and list 2, and then once we've got our data in there, we're going to go second y equals to our stat plot. We're going to enter our first one. We're going to turn it on by pushing on. Choose the histogram, which is the third one. Your list is in list 1, and we want our frequency to come from list 2. And so now we've set it up so that it's going to graph. Once we've got it set it up so that it could graph, we're going to hit zoom, and then number 9 is statistics. So we go zoom 9, and it will set up something that is not our normal histogram that we want to build. Okay? Couple other things here. Notice I have a kind of wiggly sign graph going on at the bottom. Okay? If you have anything in your y equals, it'll also graph that. Two things you can do. Either you can clear it. So I don't need these. I'm going to clear that one. But let's say it was something like, ooh, I'm going to need that equation later. I don't want it to graph, but I don't want to clear it out. Did you know that you can keep it in there but not have it graph by just pushing enter on the equal sign? And that takes it away, but doesn't get rid of it. So if you want to use that later. So now, Now if I would hit graph, I would still have this histogram that's not quite right. So after we push zoom 9, which set our window correctly, mostly we go back to our window and we go to our X scale. Mine's at 8.8, and we change it to the width that we're checking. What was the width of our intervals? Our width was 20. So now when I change that and I go to graph, I get exactly the same histogram that we're seeing that was on our actual graph. Pretty cool. Learned how to use the histogram button on our calculators today. When I was in high school, I just had a scientific calculator. I know, so old. And it was my goal in high school to see if I could learn in math class what every single button did. And so it was like exciting when I finally figured out what that NPR actually did. I was like, I have no idea what that does. I know, I was a math geek. But so now unfortunately, I think I would have been so sad if I had a graphing calculator because it has so many buttons. You hit a menu and there's so many things that it does. Like you're not even gonna, I don't know, by the time you're done grade 12, you might know maybe 70% of what this calculator does. So, yes. After you click the 9 zoom, you click on your window so that you can set your X scale to be the same width that you want your histogram classes to be. Okay, we'll end there.